Hello, let's talk about wire harness design in SolidWorks Electrical. We'll start with a software overview, then proceed into schematics, and then on to 3D, then drawings and reports, and then finally, I'll show you how to create a harness from scratch. So the common electrical design process. We all start out with drawing a schematic. Then we proceed into documentation, and we establish our bill of materials, our cut lists, etc. Then we send our document package off to a checker and engineering reviewer. They provide us our feedback, and then we repeat. And this cycle can go on and on. With SolidWorks Electrical, we have several tools that make the drawing portion far easier. And then we also have several other features that fully automate the documentation and auditing process. There's a lot of time saved because both the electrical and mechanical data is in one common database. The heart behind the collaboration are the electrical libraries. Both the 2D schematic and the 3D mechanical users can access this data. It's held in one common database. In this database, it has all of the metadata you would need to order the part, such as part number, manufacturer information, and several user-definable fields. There's also all of the symbols that you would need to do your schematics or to do your 3D models. So as you can see here by the 4 pop-ups, there are some fields in the center where you can define what you want your schematic symbols to be, your 3D part, cabinet layout, and also any connection label you might want. There's also fields for part characteristics like power ratings. Any of your legacy 3D parts or symbols can be read in. We have wizards to do that. You can also read in Excel spreadsheets and text spreadsheets to populate the part number, manufacturer, and several other fields. So enough of the overview. Let's proceed on to the schematic 3D drawings and reports. The schematic I had created. I've already placed all my symbols and made all my connections. I've also gone in and defined what I wanted for all my manufacturer's parts. For this example, I've got my back shell, 6 pins, and an environmental seal. When you look at a net like this, it's not easy to tell from a logic diagram where the wires start and end. So they're obviously daisy chaining, but where do they start? Do I have 2 wires coming in here or 1? Well, there's a way to define that, and it's the wire cabling order. So I had picked on that net, and it's showing me all the different points that belong to it. Down here, it's telling me the flow. So you could say the first wire starts at T31 and feeds into connector 6, pin 3. And I can see down here there's another one. So it's telling me it daisy chains from T31 into C63, and then to C73, and then 48, etc. And you can actually see down here where it says C48 that there's 3 wires going into that one pin. If I want to change any of those, all I have to do is click on the line that I want to change, select which point that I want to replace it with, and then pick if I want that to be the new origin or the new destination. I actually like mine how it is, so I'm just going to leave it. And let's jump on into the 3D. So this, as you may have guessed, is a freezer. And the harness is going to run around the back. I had already placed all of my mechanical parts, and had gone in and predefined a sketch where these are all going to route to. And these are just guidelines to tell it where it's going to go. As you can see, not everything is fully connected. Doesn't need to be. Just go ahead and tell it the route. And that's it. The harness has been routed. And if you look down here, you notice some lines are gray, some are green. Well, this only had 1 wire going into it. It was one of the green ground nets. So only 1 wire comes out of here, but then it starts to daisy chain out of this connector. And that's where you see the gray. It's representing that there's multiple lines. So now that we have our harness routed, how do we get to the drawings? It's as simple as clicking Flatten Route. You can choose between an annotated view and a manufacturer's view. A manufacturer's view is a form board drawing and true to size. The annotated view compresses things so they'll more easily fit on a drawing. You can come in and manipulate this. If there's anything that you don't like, say you want to move some of the connector positionings or adjust the lines, it's as simple as clicking the different line segments and using the tools on the left to adjust the segments, the fan outs, etc. Once you get it positioned how you like it, you can go ahead and flatten the route again to get your drawing. You can select which templates you have predefined, if you want any of your cut lists or tables to appear. I'm just going to let the bomb appear. SolidWorks Electrical uses all the capabilities of SolidWorks routing. So if you're familiar with routing, then this should all be very familiar to you. As you can see, it's gone through and auto-ballooned my drawing. All my segments are dimensioned, and I've got all my part numbers. So creating drawings is as easy as that. Let's jump back into the electrical tool, and I'll show you some of those reports. There's several predefined reports that you can add, but you can also customize them as much as you would like. You can come in and add more columns of any of the data, but if there's anything that doesn't quite suit your needs, there is a button down here that you can activate, which is a SQL editor. So any data entered anywhere in SolidWorks is yours for using. You just have to write a query to create a new column type. So for example, some of the reports I'd created, this is a bill of materials sorted by part number. So you can see everywhere where that part number is used and the quantity of them. Another bill of materials that I made, I sorted them by mark. So you can see which parts are required to build up each individual component. And I also have my cut list, where I can see the wire numbers, their colors, how much of that wire I need, and also their from and to. Is it a male pin or a female socket, and which back shell are they in? So now that you've seen an overview, jump into that harness from scratch part. For starters, let's actually start in the mechanical space. This is my standard parts library. I'm going to go ahead and add a connector to this. It's a dumb connector I had downloaded off the internet. This one right here. So now you'll notice on the left, and this will make more sense later, but it's a dumb part. There aren't any extra features that are giving it any intelligence, which you'll see will appear later. So let's start by building that part up in the library. Now here are those fields where we define what symbol and 3D part we want to associate for this manufacturer's part. So what I just did there was I made the part electrically intelligent. To make it mechanically intelligent so it'll route all the wires though, let's jump into the mechanical space. So here's that same connector, and I'm going to start off with adding a few points to it. This is an unnecessary step, but it does make things a little bit easier when we jump into the wizard. So in the electrical component wizard, it's how you define panel and rack mounted components, how they will auto snap when they are brought into the 3D environment. and where all of the wires will spring from the components. So it's prompting me to create 3 connection points, since in the library manager I had told it that it had 3. If I had not defined it initially in the electrical side, you can do it in the mechanical side as well, since you have access to the same manufacturer's parts manager. That's why I created those sketch points. It's easier to pick a point than it is to snap to the center of the ring. So now the part's intelligent. As you can see over here, these different fields. You can also come in, and if you so wish, you can adjust the stub lengths and a few other properties. Now, one thing I like to do so that all the wires gather in the center is add a little bit of a routing path. Now, when I'd shown you the large schematic in 3D, and I had initially drawn a sketch down, it created a large 3D routing path beforehand, but you can also put them in subcomponents. This just lets you create a 3D sketch on the fly. What this will do is when the wires initially come out, they will try to bend in and snap to this line before they run off to their next destination. So now that we defined that in our library, let's go ahead and use it. You can either add a symbol and start designing that way, or if you know what your parts are ahead of time and build it up like a kit, you can do that too. You can go in by adding components to your component navigator without placing anything on the page. Similarly, another way is the mechanical engineer can add things into the 3D space, and they will appear in this navigator as well because he has the same navigator in SolidWorks. When selecting a part, you can either search for it by classification or use the filters. And as the last manufacturer used was Vance, that's what it's displaying. But there are many different manufacturers to search for and many different fields to use. This was that component I had created. Just going to go ahead and double click to add him. So now that I've predefined him, if I go into SolidWorks, you'll see shortly where it'll say insert solid part. Since I'm on a schematic tab, it's telling me to insert symbol. If I go to line diagram tab, it'll ask me to insert a line diagram symbol. So that's a common element with the libraries, is it knows which page type you're on, and it's telling you it has data that you can add for that part. Now I can add another component the same way, or copy and paste this one since I want the same part number. You can see it automatically incremented to P2, kept all the other metadata the same, and gave me another component over here. I'm going to connect these with some wires, give them some numbers, and add this to a harness. So now you'll see in 3D, my 2 components were added to the mechanical space. You can see they had blank checkboxes telling me that there were parts available to be inserted, and now they're checked saying that they are. After they're brought in, you can go ahead and adjust their positioning with mating. Just move them around, which I'm going to do a little of right now. What to do is hit Route Harnesses. And it's as simple as that. I hope you enjoyed this introduction to harnessing with SolidWorks Electrical. Thank you.